be looking at lesson 51 and lesson 52. We'll do them individually. You will have homework from lesson 51 tonight. Lesson 52 homework we'll do in class tomorrow, so you don't have homework on Wednesday night. All right, we'll have time. You should have time to finish it. You will have to finish whatever's left, but there's enough time in class to finish it tomorrow. Lesson 52 is pretty important. All right, so lesson 51, again, we're dealing with rational expressions. Rational expressions are algebraic expressions that have variables in the denominator. All right, so we're going to be simplifying fractions again. We're going to be adding fractions, and the rules for adding algebraic fractions are the same as the rules for regular fractions. We're just going to that's what this lesson has to do with, lesson 51. One important concept is, and this is not new, none of this first stuff that we're doing is new, values of a variable that make a denominator 0 must be excluded in rational expressions. So we need to at least be mindful of the values that are excluded from our expressions when we are working with these things. For example, what value of m is excluded in this particular expression? M cannot be 0 in this expression, because if m equals 0, then our expression is undefined. 5 times 0 is 0, so 0 in the denominator is a bad thing. 0 underline is undefined. Okay. Number 2, 5m over m plus 1. M cannot equal -1, because if m equals -1, we would have a value of 0 in the denominator. Now, we had a question similar to some of these. This is not new again, so we had this in the last unit. We had a question similar to this one on the test, and some people did something like this. Is that allowed?
Yeah.
Why is that not allowed?
They're not like factored or the factor.
Because we're only allowed to cancel factors when we're simplifying expressions. Now, the m in the numerator is a factor, but is the m in the denominator a factor? It's a term, and you can't cancel terms or parts of terms. All right? You can only cancel something that is a factor of the entire numerator or factor of the entire denominator. So in this case, though, we're just looking at excluded values and then moving on. All right? Now, to add fractions, the fractions must have what? Common denominators or like denominators. Either one of those would be correct. The denominators have to be the same in order to add them. All right? Now, if they are the same, what's the process for adding fractions? You add the numerators and the denominator stays the same. So if we had something like 1/6 plus 3/6, we get 4/6, which simplifies to be 2/3, and we always need to make sure that our fractional answers are simplified. That's true for algebraic fractions. It's true for regular fractions, either way. All right? So to add fractions, the fractions must have like denominators. That's true for algebraic fractions or rational expressions. The numerators can be added and the denominators do not change. All right, so if we're adding algebraic fractions, in other words, fractions that have variables in the denominators have to be the same in order to add them. And if the denominators are the same, then we just add the numerators or subtract the numerators, whichever rule applies, and the denominator remains unchanged. Okay? Y'all copy what you want to copy there? All right, so the process for simplifying fractions involves canceling common factors. Again, this is all kind of just review, right? We can only cancel common factors. For example, we just canceled 4/6, right? We said that was 2/3. The reason it's 2/3 is because we can cancel a common factor of 2 from the numerator and the denominator, and we're left with 2/3, all right? So you guys are kind of used to thinking about the process differently, but what we're doing is canceling a common factor of 2. Your elementary teachers probably said you're dividing the top and bottom by 2. Well, that's the same as canceling a factor of 2. It's just division doesn't translate into algebraic things. All right, so to simplify any fraction, one must factor the numerator and denominator to find the common factors and cancel the common factors. All right, so let's have a look at this. And this says simplify the following rational expressions. Simplifying a fraction involves canceling common factors between the numerator and the denominator. So you can tell me what this would be. 2h over 3 is on the table. Right? What would that be? What would we cancel if we did that? So this, the top is 4 times 2 times h times h, right? And the bottom is 4 times 3 times h. So we're canceling a common factor of 4 and a common factor of h, and we're left with 2h over 3, right? Any restrictions on this answer? H cannot equal 0. All right. Yes, sir.
On everyone we answer, do we have to put?
I would like you to. I really would like you to. And because we're qualifying this equal sign, right? If h equals 0, this is really, really bad at h equals 0. Right? You get 0 over 0. That's undefined. If h equals 0 here, we get 0. H equals 0 works there. H equals 0 does not work there. So this expression is only equal to this expression as long as h is not equal to 0. So it's important to have that disclaimer there. And that's a little advanced. If this were a regular algebra class, I might just say, think about it, but I'm not going to require it. But I want you guys to be able to do that. I want you to think that way. This is not always equal to 2h over 3. It's not always equal to 2h over 3. It's only equal to 2h over 3 if h is not 0. Okay? All right? All right, so let's have a look at this one. What can we cancel right now?
The M? Wait, well, no.
No.
You can't.
The m is a part of a term, right?
Could you reduce the 3 and the 6?
3 and the 6 are terms also.
Oh, yeah. So you can't.
Right?
Nope.
Simplify?
We can't simplify these two things.
Wait, can you?
We have to factor, right? If we're going to simplify a fraction, let's go through the process again. The only thing we're allowed to do to fractions to simplify them is to cancel common factors. And the only way to find common factors is by factoring the numerator and denominator. In this case, the denominator can't be factored, but the numerator can be factored as 2 times m minus 3 over m minus 3. Now the m minus 3's can cancel. And this thing right here that we started with is equal to 2 as long as m is not equal to 3. If m is equal to 3, if m is equal to 3 over here, this is not equal to 2. Right? See, so we're qualifying the equal sign by saying that the original expression is equal to 2 only if m is not equal to 3. All right? Is everybody okay with that? All right, try this last one on your own, see what you get. All right, what would we do here?
Factor.
Why do we have to factor it?
Cancel.
Because we're only allowed to cancel common factors, right? And we find the factors by factoring. So we factor the numerator as 4y times y plus 2 over y plus 2, right? Y plus 2's cancel, and we're left with 4y. Y not negative 2. Because if y is negative 2, if we put a negative 2 in there, right there, what do we get? Negative 8, right? If I put negative 2 up here or up here, I get 0 over 0, not negative 8. Right? So these things are only equal to each other as long as y is not equal to negative 2. Okay? All right. Adding rational expressions. Again, the rule for adding rational expressions is to make sure that the denominators are the same. And if the denominators are the same, then we can combine the numerators and keep the denominator. All right, so in this case, the denominators are the same. So I can subtract these two terms, and what do we get when we do that? Negative 1b over a cubed, right? Which you could just write as negative b over a cubed, right? Either way, I don't care if you put the 1 there, it's fine. Good? No, it can be out front, up top, or in the bottom. As long as there's only one of them. Yeah. All right, what about this one?
Change the line or whatever.
Now, we don't have like denominators the way it's written, do we? Can we leave this problem like that? Why not? Negative exponents are not simplified. It's not in a simplified form if the exponents are negatives. We don't want to, at this point in our mathematical lives, give an answer that has a negative exponent. When you get to calculus, that won't be as big a deal. All right? P over Q squared minus, what would this next one be? 7P over Q squared. All right, so when we get rid of the exponents, negative exponents, we end up having like denominators. All right, so then we're left with P minus 7P, which is negative 6P over Q squared. Can anything be simplified? Do we have to put an excluded value here? Can we put an excluded value? Q cannot be 0. Do we have to put the excluded value here? We don't, because Q equals 0 breaks every piece along the way. Right, so it's not necessary. We don't have to qualify these equal signs because these expressions are all broken by Q equals 0. It's understood that Q can't be 0, but even if Q was equal to 0, these three things are still equally awful. Right, Charlie? Because it's currently being divided, right, by this. And that P comes up, what's the inverse of division? Multiplication. So as soon as the P moves upstairs, it's still, it becomes a multiplication process. It's a good question. Okay. Last example from this lesson. A rectangular field has a length of 6a over 3a plus 4 kilometers and a width of 8 over 3a plus 4 kilometers. Find the amount of fencing needed to enclose all 4 sides. Now, how in the world would fighting with swords have anything to do with closing the sides?
Oh my.
No, it doesn't work.
No.
I mean, if Elijah and I got some swords and go out there and fence, say if we fenced for 3 hours, would it enclose the?
No. That was an awful joke. That was awful.
I know.
I still don't get it.
Fencing.
Like
Sword fighting.
With the gun guard, is that a shame? Oh, that's not what it's talking about.
Oh my
Let's talk about like y'all.
All right.
Good job.
Okay, are y'all ready?
Can I walk out
So
the room now?
the perimeter is 2 times the length plus 2 times the width, right?
Yeah.
So we could do 2 times the length, which would be 2 times this is 12a over 3a plus 4, plus 2 times the width, 2 times this is 16 over 3a plus 4. All 4 sides is the perimeter, right? I mean, we make that deal. So then we're left with, our denominators are the same. We can't combine 12a and 16, but we can write this as a single fraction. 12a plus 16 over 3a plus 4. We need to check it, right? We always have to see if the fraction can be simplified, which means we need to factor the numerator and denominator to, so 4 times 3a plus 4 over 3a plus 4. And we're left with 4 hours of sword play. 4 kilometers of fencing. All right. Now, no. If you're multiplying it by 2, you're multiplying it by 2 over 1.
That's what I was.
So yeah, that's good. That's a great question to ask. Now, let me ask you this: do we have to do any exclusions here?
No, because if it's 0.
Right. A could not equal negative 4/3.
Yeah, that's what I was thinking, like 4/3.
No, we don't, because these would be meaningless if A was equal to negative 4/3. So A can't be negative 4/3. In the context, we don't have, we're talking about physical lengths of things. So we're not going to have an undefined length. So we can know that A is not equal to 4/3. It'd be okay if you put it, but it's not a necessary thing in this problem. All right? And y'all never knew that playing with swords can actually enclose a piece of property.
Oh my goodness.
And now you do. All right, here's your homework from this lesson.
All right, guys.